Let's start section 3.3. We're talking about zeros of a polynomial function. Our goal is to find the zeros. And we already know how to do this if the polynomial is degree 2. That's just a quadratic function. So let's have a quick review of that, and then we'll move on to degree 3 or higher. So remember, zeros are just x-intercepts. The only difference is that a zero doesn't have to be a real number. It could include the imaginary unit I. So how do you find zeros? How do you find x-intercepts? All we do is just set y equal to 0 and solve for x. So let me give you an example. Suppose we have f of x is equal to x squared minus 4x minus 5. If we want to find the zeros, then solve f of x equal to 0. Remember, f of x is the same as y. And so what we do is we set the function x squared minus 4x minus 5 equal to 0. And now we just have a little quadratic equation to solve. And the first thing we want to do to try to solve a quadratic is we just want to factor. So let's see here. X minus 5 times x plus 1 will do it. And remember to set each factor equal to 0. And solve for x. So x equals 5 or x equals negative 1. And so there's an important result here. 5 is a 0 because x minus 5 is a factor. Five is a 0 because we have the factor x minus 5. Well, that's what the factor theorem says. The factor theorem says that for every 0, for every solution, there has to be a corresponding factor. And vice versa. For every factor, there has to be a corresponding 0. So x minus 5 makes the solution 5. X plus 1 makes the solution negative 1. X minus k makes the solution x equals k. Makes the solution x equals k. So if we want to find the zeros for a polynomial of degree 3 or higher, then you might guess that we want to factor the polynomial. Factoring degree 3 or higher is a lot harder than factoring a quadratic. And specifically, what we have to do is we have to use synthetic division to factor the polynomial. So we'll have a couple examples here to get us going. The first example says use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. So let's see here. We have a function f of x. It's a 4th degree polynomial. We have x minus 1 as the potential factor. And so what is the value of k? So this means k equals 1. And so we want to use synthetic division to check and see if 1 is a 0. If 1 is a 0, then x minus 1 is a factor. Out in front, we put the 1. Inside, we put the 2. Notice x cubed, the x cubed term is missing, so we'll put a 0 for that. And then 3, negative 5, and 7. And then we'll go through the synthetic division. We have 2, 2, 2, 2, 5, 5, 0, 0, and 7. If I went through that a little fast, you might want to go back and practice the homework in section 3.2 a little bit more in order to review the synthetic division. So let's see here. What's the remainder? The remainder is 7. This means that f of 1 is equal to 7, which is not 0. So we can say 1 is not a 0. And I guess so far we've done all of this in the previous section, right? And then the new idea is to take it one step further and say if 1 is not a 0, then x minus 1 is not a factor of f of x.